All right, my name is Erwin James. I'm a product manager for Nokia, and I work on both the SR Linux network operating system, which you may have just heard Bruce talk about in a previous session, as well as our Fabric Services System product, which Bruce had also mentioned in a previous session. And I'm going to do a demo today for you on the Digital Sandbox aspect of the Fabric Services System. I just have 2 or 3 slides to context set, make sure we're all aware of what I'm going to be talking about, and then I'll jump straight into the demo and then hopefully take it from there. Okay, so just a very high level summary of what Fabric Services System is. So FSS is our data center fabric management solution that is part of the DC solution, so paired with the hardware and the network operating system. This fabric management system is intent-based, and we handle all management from what we call day 0, which would be, typically your design phase, design of your data center from topologies to configuration, down to day 1, which is basically your provisioning of the switches. So you stand up your devices, and also, of course, day 2+, which is your operations. So change management, alarming, monitoring, performance monitoring, and so on and so forth. Just a quick note on the actual product and the platform itself. It's entirely built to run on Kubernetes, and it's entirely microservices based. So we'll take a look at that in a second. Why that's important from an architecture standpoint is it allows us to scale various aspects of the system horizontally based on load, right? Now, you don't have to be too worried about it. We don't require you to have Kubernetes knowledge to install Fabric Services System. We'll be happily ship you a VM appliance to run it. However, if you do have the expertise in-house, you do have Kubernetes clusters in-house, and you do want to instantiate this on one of those clusters, that's an architecture that we can support based on how we develop the application itself. One key aspect of Fabric Services System is a Digital Sandbox. So the Digital Sandbox is basically our answer to having a digital twin for the network, right? So even today, when we talk about Container Lab and the other tools out there that allow you to build up virtual environments, these are great tools that allow you to spin up, potentially small labs on your laptop, right? So you can pair that containerized version of SR Linux with Container Lab to spin up some small topologies on your laptop, get familiar with the operating system, get familiar with the topology. If you want to scale that out, you have to scale out the resource. So if you want to spin that up on a large beefy server, that allows you to spin up these containers on that. What we do with Digital Sandbox in Fabric Services System is actually allow you to instantiate this on our Kubernetes cluster. So you can actually horizontally scale these containers, so you can have a topology which is potentially extremely large in size based on the size of your Kubernetes cluster. And I'll get to that in more detail in a bit in the demo. So this demo is, again, I'm going to walk you through a bit of the UI of Fabric Services System. But really, the focus of the demo is that Digital Sandbox, is that digital twin functionality and what we bring to the table with Digital Sandbox. So why do we need digital twins, and why do we need a Digital Sandbox for our network? Well, the primary reason is actually to de-risk that change, right? Change management. So change management can be, planned change. You're about to add ACLs, you're about to add BGP policies, and you want to de-risk that change. So typically, you would try and validate that in a lab. In our case, that lab becomes digital. That lab becomes an exact copy of what's in your production network, right? You may potentially be introducing a CI/CD pipeline, as Bruce talked in a previous session as well, right? So maybe you're starting to introduce that concept of making those changes more frequently into the network. But of course, as was brought up in a previous session with regards to changing the network once a year, or potentially, once every 6 months if you're adventurous. The reason you do that is because you don't want to have to go through and make changes which potentially could be service impacting. And so what you have to do is de-risk those changes, right? And so what a Digital Sandbox brings to the table is the ability for you to de-risk that change such that you feel confident that when you actually push this into production, you will actually get the desired result, right? And the last piece of the Digital Sandbox, which provides a lot of value, is upskilling staff on network operations. So of course, you can spin up environments, virtual environments, more and more easily these days, and that gets you familiar with the network operating system. What happens on the network operating system provisioning, BGP peers, understanding the effects of doing so, understanding the CLI constructs maybe, or potentially if you're getting into automation, you're understanding the interfaces, whether it be GNMI or netconf or other. But really what we want to do with Digital Sandbox as part of Fabric Services System is integrate it really tightly into the platform itself. such that the workflow from an operator, the workflow from the ops team is identical whether they're configuring a real network using Fabric Services System or they're configuring a Digital Sandbox, right? And everything that goes with that. So if I bring up an environment in my Digital Sandbox environment, I will get the exact same alarms if I wanted, optional. I can get the exact same alarms if there were to be issues in my Digital Sandbox. And the steps I take to provision the network, whether it's a real device or a Digital Sandbox environment, are identical. So if you want to upskill your operations staff in understanding what happens when they make a change to the network before they actually make the change to the real network, the workflow, the steps, and their end result when it comes to what actually happens in the, whether it be the UI or potentially to the API, is identical between both of them. So I'll jump in and get into the demo. One last aspect of Digital Sandbox, which is really important, it's actually a core piece of the demo, is the fact that we can actually do state synchronization between the real network and the digital twin. So what that means is that we can actually tell the Fabric Services System that this is a production network, this is a real devices in the network, and I'm about to make a change to that, but I want to de-risk that change, right? Now that change could be through the UI, which I'm going to show you here. It could also be obviously through the API if you're tying it to a CI/CD pipeline, right? But I actually want the network and the digital twin to be a reflection of what's actually in my network today. That means that if there's an interface that happens to be down in the real network, I want my test that I'm running in my Digital Sandbox to reflect the fact that there's an operationally down port somewhere in my network, right? Because those are the types of errors that are very difficult to catch, right? Yes, of course, you're going to have an alarm and know that the port is down. And maybe potentially you're making a change to actually remediate that problem. Maybe there's a port down, you're aware of it, it won't get fixed until next week based on whatever reason. So you want to apply some BGP policies to reroute your traffic potentially, right? Where a lot of issues happen is when you start making these changes and it's a cascading effect. You didn't realize that something else was in a bad state, and then that caused a kind of trigger effect of potentially, bigger and bigger problems, right? And so what you want your digital twin to do is actually say, I'm going to run these tests. I want to change my BGP policy in my digital twin. And I want the state of my digital twin to be a reflection of what's in the real network. And so if something happens in a real network, I want my digital twin to actually represent that. And I'm going to show you that in the demo now.
So that includes manual changes that were done by somebody on a device that were not done through the Fabric services?
Exactly. So there's actually two steps that I actually show in the demo as well is, of course, if you make a change in the CLI, we reflect that in the system and say, hey, there's a change. Someone made a change here, and that's not part of the intent, right? So part of an intent-based system is you give us a set of inputs, and we will make sure the system is always in a desired state, right? That's a fundamental of an intent-based fabric management system. So of course, if someone comes in and changes a CLI, we need to let the Fabric Services System know and the users of that system know, hey, there's something that's not as per intended, right? And then you have the choice. You either say, actually, you know what? I accept that change. That was a correct change. That was planned. Someone went in CLI and I accept the change and now it becomes part of my intent. Or you would say, actually, you know what? That is not planned. Set the system back to the desired state, right? And I can show you that in a demo in a second.
As far as the digital twin modeling,
yeah,
is that just for Nokia?
Today it is. Yeah, exactly. Today it is. So actually, we leverage that containerized SR Linux that Bruce talked about in a previous session. In fact, the exact image that you can pull down right now from the Docker registry, we use that identical image in our digital twin here. And we have the architecture and the platform to extend it to other operating systems. Certain things, like for instance, the state synchronization, are unique to our solution, right? Because what we're actually doing, you can imagine that if there's a port that's operationally down in a real network, if I bring up my digital twin, I need to have the ability to set that state leaf inside the digital twin to be down, right? So I need to go to the actual containerized operating system, an interface which should be up. So if you weren't doing state synchronization and you brought up the interface between two switches, it should be operationally up. And if you did this without state synchronization, you wouldn't know that the port is actually down, and you have to have the ability to set that operational state on the digital twin. And so that's kind of unique to our solution, because I don't know of any other operating systems where you can actually set operational states rather than just setting configuration leaves inside operating systems.
Yeah, no, I was just comparing and contrasting in my head this so far, what we've seen anyway of this with like forward networks, right? Which does the digital twin, same thing. Not same thing exactly, but
Well, the big difference is one is a mathematical model,
yes,
and one is a real actual digital twin with state. And that's a big difference, because in a real network, state is everything, right? So we can provision things and we can say this should be an ideal representation of the network based on a set of inputs, right? We can do a mathematical model or other, figure out what it should look like based on the inputs which are provided to the system. But we also all know that in a real network, things like transceivers go down, right? And in an operational state may not be true. And when you're doing when the end goal is multiple changes on your network to get to that utopian world that Bruce talked about, where you're iterating changes on a monthly basis, or if you're being super aggressive on a weekly basis, then you want to be able to make sure that the moment before you make a change in a CI/CD pipeline, you've baselined against what is actually in your network right this instant. And that means that if there's a port that's down, you're testing against that to make sure that that doesn't impact your change, or maybe it does impact your change and you catch it, right? And so rather than running mathematical models and what if scenarios, you're running in this moment in time, what is actually the output if I were to make the change right now, right? That's kind of the difference between the two models.
Okay.
Well, you're exercising the real code as opposed to what somebody sort of modeled in terms of inputs and outputs, which may be missing some subtle or low frequency occurrences of the actual code.
Well, also, and to that point exactly, not only we were actually running the identical code that runs on the hardware, right? So that is SRL container, which is on the registry. That is line by line code identical to what we run on the switches. So if there happened to be a bug, we hope there aren't. If there happened to be a bug in the BGP stack, those are the things you want to catch, right? And a mathematical model isn't going to catch a bug in BGP for you, right? You could say, what if BGP went down? But the outcome of that and the resultant state is what's important, because that was what triggers the next outage, right?
So you can
Terry
pull that
Slaughter and I have been having discussions around the degree of fidelity you need in a digital twin, and for some cases you need this level.
Yeah, we believe so, of course. Yeah.
As part of a CI/CD pipeline, you're going to be doing a lot of testing.
Yeah,
and that's where you're trying to go with this.
Right.
So, in order to test forward with your digital twin, would you be able to have that run a newer code? So let's say it's BGP microservice that gets changed.
That's exactly it. Yeah.
Pull that down. Yeah. Upgrade your twin to the newer version.
Correct.
Run your code through that.
Exactly.
Then deploy that into your production environment.
That is exactly the use case. That is one of the low-hanging fruit use cases that we're targeting, is an actual upgrade of the software. And if we then extrapolate that to what Bruce was saying about our capabilities inside SR Linux to not just upgrade the switch image, which is the standard procedure nowadays, is you upgrade the image on the software. It's actually we can upgrade individual applications. And so now you can start upgrading individual applications on a more regular basis, but you could also de-risk it in a proper CI procedure in your pipeline in the digital twin first. So you can take an exact digital twin, which I'll show you how to do in a second, and say, now my process in my CI/CD pipeline is actually to upgrade a set of my nodes. What will the impact be? So I'm going to build my digital twin, potentially state sync, optional, right? And then upgrade my set of switches. And what is the result after that? If I'm confident and I can pass all my test case and I feel that I've de-risked that change of doing an upgrade, whether that upgrade be an individual application on the switch or the entire set of applications, then I can then push that to production. And that's the general idea. Yeah. Okay.
Like each of these devices that are, they're probably running like a container or something that takes the scripts. So like, does it mean like these containers are like speaking to themselves in each of these devices while this stuff is happening?
Yeah, so all the containers in the digital twin talk to each other as if they're built like this. There's the same topology as in a real network. So we actually instantiate the entire topology in a Kubernetes cluster, and we stitch the correct ports and the correct interfaces to each other as per defined by the intent in the Fabric Services System, which I'll show you here, which is what's actually running in your production network. So we handle that stitching for you, right? And we do this in Kubernetes. And the reason that I keep rehashing it's important is because you can imagine that you're now exposing this to a set of users, which may all want to build their own digital sandbox for their own change, right? So they could just be manual through the UI like I'm about to do now. Could be CI/CD, where there's a lot of systems making changes or potentially wanting to test a change, not necessarily making the change. And so they want to spin up their own copy of it, right? So to do that, you need to be able to scale that topology, horizontally. So you need to scale it beyond your laptop, beyond a compute. You need to scale it on a cluster, and that is where the architecture of it supporting topologies on a Kubernetes cluster allows you to consume hours. Like as I said, I can give you a VM with FSS, which has Kubernetes installed. Or if you have the knowledge in-house to have a larger Kubernetes cluster, you could actually leverage that and build these larger digital sandbox topologies to match the size of your network if you wanted to. Okay, so I'm going to log in. So quickly in the demo, I'm going to log into the UI. So everything I'm doing here, I'm going to use the UI and the CLI because that tends to translate to demos a little better than me running code. But of course, we have a full set of APIs for Fabric Services System. So if you want to tie this to your own CI/CD pipelines and other, you can do so. Okay, so for the sake of time and the demo, I've gone and pre-configured a few things. So I'm just going to run you really quickly through it because I think I'm running a bit short on time already. This is the Fabric Services System UI. So this is where you go as an operator through a UI interface to configure fabrics, right? To bring in topologies, to instantiate the fabrics, to the ZTP bootstrap the switches, as well as then deal with alarms and all the day two changes you want to make. So maybe bring in ACLs, BGP policies, and so on and so forth. We have this concept of fabric intents, which is basically from a data center perspective, you can think of that as a topology plus an underlay configuration. And then we have these workload VPN intents, which is basically EVPN, VXLAN services that you're instantiating on top of that underlay, right? So I already have a couple of fabrics deployed. I have a real fabric, so you can see the fabric type here is set to real. So I have some real devices out there. And if I look at what we have today, we have topology that's actually quite small, but it's just because of the size of my lab. I have three switches, very simple. I have a spine and 2 leaves. So this is real network that's deployed in my lab. This is my data center. And I've already provisioned all the inputs into the system from an intent perspective. So I've told it, the IP pools it can consume IPs from. I've told it the ASs it can consume ASs from. And then the system has gone and actually generated all the configs on my behalf. I can look at the configs, right? So for every device, I can look at the configs. And then I've actually pushed this to my devices. So my device is up and running. Now, as an operator, I'm about to make a change. I want to bring on a new service, but I want to de-risk that change, right? So I actually want to test my change in a digital sandbox. And using the exact same UI, the exact same inputs, and the exact same API, I can actually spin up a digital sandbox version of it. So I've already spun one up, but I'm going to do one for you now and show you how simple it is as an operator to take a production topology to production network and actually build that up as a digital twin in my my Fabric Services system. So I'm actually going to pick my real network, which we just looked at, and I'm going to duplicate it. So what I'm saying is take all those inputs that built the real network and build me a digital twin fabric based on those same inputs, right? That's what this magical duplicate button does for me. So I'm going to build a new fabric. So I've duplicated all my inputs. I just have to tell it, am I building another version of the real network, or am I building a digital sandbox? In my case, I'm building a digital sandbox. So I'm going to name it Digital Sandbox Fabric 2. I'm going to add a prefix for my naming convention. And then I'm going to generate the fabric. So as you can see, it looks identical topology-wise to what I just looked at in my real network. And likewise, I've gone and generated the configs for it. So I can go look at the configs just like I did for my real network. Again, the workflow from an operations standpoint is identical. I'm not jumping to a separate tool set to build a lab to play with and then copying configs over and hoping my topology looks the same. I'm literally using the same workflow. Okay, so from here, what I'm going to quickly show you is I've built this topology, and maybe I want to make some changes to the fabric. Now, in my example, I'm not actually going to make changes to fabric, but you can imagine I could go make changes to fabric links. I could go make changes to label assignments. We use a lot of labels in how we provision devices in Fabric Services system. But in my case, I want kind of like to like, one for one. I'm not actually making changes to the fabric because the change I want to make is adding services on top of it. That's where my change is. So I'm going to just tell the system to instantiate this in Digital Sandbox. So I'm going to switch quickly to my terminal, where you can see this is an application that's showing my Kubernetes cluster. So like I said, you don't need to be worried about having to understand and manage Kubernetes as a whole. We'll take care of that for you if you want to. But this is an FSS deployment on a Kubernetes cluster. And what I want to show you is when I actually ask FSS to instantiate a, oops, so let's go down here. I've lost connection. Oh no, we're back. Okay. I'm going to jump down here. So we're going to see, hopefully, in this area, so I happen to know the namespace is going to instantiate on, but hopefully we're going to see some pods get instantiated. So it's actually Fabric Services system building that digital twin for us. So I'm just going to tell the system to update Digital Sandbox with our new topology that we just created. And so what's actually going to happen here is we're going to instantiate containers. The containers are going to come online, and they're going to come up and call home to the Fabric Services system and say, hey, we're operational. We're ready for you to perform tests going forward if you want to. So if I jump back to what's happening in Kubernetes, I hope I didn't miss it. I did miss it. Okay, these pods have been up for 15 seconds. You can see on the right-hand side. So these pods here just got spun up by FSS. And if we look at what actually belongs in one of these pods, of course, it's that SR Linux container we looked at, right? But additionally, we actually do things beyond just spinning up a topology. We actually have extra tools and tool sets available for us to do traffic capture, traffic generation. If you attach workloads to it, so you want to simulate the actual servers on the top of rack, right? So it's one thing to bring up the virtual topology, but in order for you to represent a server, you need something on the other side in the virtual topology to bring the interface up, right? And so we take all that care of that for you. So if you attach a sub-interface in an EVPN VXLAN environment, then we assume that you are expecting a server to be attached to that, and therefore we will actually bring the interface up on your behalf using some simulators that we spin up in the topology. So we do things beyond just setting up a topology. We actually complement it with a tool set to make the digital sandbox feel like the real network, right?
How aware of it is those overlay services? Does it know this goes from that port to that port, and can it actually traffic between those two?
Yeah, exactly. I'm actually going to show you that. So I'm gonna spin up a workload, and I'm going to do a classic network test and do a ping between two works so you could see the traffic going across the digital sandbox.
I demand iPerf.
iPerf, well, if you know what, I'll do it. If the image I have on there does iPerf, I'll do it, but I haven't checked. So, but I'll take the challenge if it's available. Okay, I'm just going to push these changes to my digital sandbox, and then I'm going to move ahead. So, Workload VPNs is where we create those overlay services, right? This is where we create. So we have a fabric deployed. We want to create EVPN VXLAN overlay services between our servers so they can talk to each other. This is where we would do this. There's already one existing, and I'm just going to use this because of the sake of time. But if I wanted to create a new one, just really quickly, I could click here. We have templates, right, that we package with the system, so you can build these overlay services, and we take care of the complexity of dealing with, you know, ESIs, EVIs, RTs, RDs for VPN, and so on and so forth, just like any kind of abstraction layer intent-based system should do. And I've already created one, right? So I've already created a workload here. It's pretty simple. I have two subnets, subnet 1, subnet 2, not very complicated. They both have bridge anycast gateways, right? So your servers should be able to hopefully use those as gateways. I happen to have attached one subinterface from my one leaf, right, and my three node topology to one subnet, and then the other to the other, right? So I've done this ahead of time for the demo, and I'm now just going to jump into these devices and send the ping between them to make sure that they actually function, right? So let's just jump into that really quickly. So now we get to our trusty CLI, which is mandatory for networking demos. I'm going to, I've jumped into the simulator. So you can see on the screen already from the previous command I issued earlier that in my digital sandbox environment, if I'm using the CLI, I can see that I have my topology, right? I have leaf1, leaf2, and I have spine1, which is that topology we showed earlier. Additionally, we have that SIM0, right? So I talked about the ability for us to attach servers, right? Access side endpoints to the top of rack switches or leaf. We do that's what we call SIMs, right? So we'll do that for you. So when you build a topology and you say, I have two subinterfaces attached on these two TORs, then we take that to mean that we should bring up a simulator or some device that we can spin up and bring up so that this will be operationally online, and then potentially do some traffic generation, traffic capture, pinging, so on and so forth, right? So I'm currently in that simulator, right? So I jumped here, this command here, I jumped into the simulator, and I happen to have gone ahead of time and checked out what IPs we generated. But we've actually instantiated IPs on these simulators on your behalf, so you can actually ping across that network, right? We looked at those two IRB interfaces. So if I do a ping, hopefully ping works, okay? So
And it didn't crash.
and it didn't crash, which is a huge bonus. My ping is clearly better than Bruce's, right? He's not. It's going to be an ongoing joke from now on out for sure.
Gonna remember forever.
Yeah, just remember him, right? Remember, he's the ping guy, right? Okay, so I'm pinging. So what am I actually doing? So if I jump to this terminal, I have on the top layer, I have one of my digital sandbox SR Linux instances. I'm logged into the CLI, right? So this is the switch CLI, but this is my digital twin version. On the bottom, I have the equivalent real node, right? So remember, I built a digital twin of a real network. Well, the bottom terminal is the actual real switch. And the top session is the digital version of that real switch, right? And the ping right now is happening here, right? It's happening across my digital twin, right? So if I do something like a monitor on change interface Ethernet 31, that's my ISL, my uplink between my leaf and my spine, and I'll do in octets. So now we should see this number is going to increase, right? But this goes my ping, and if I stop it, hopefully, this should also stop, or at least be very close. There's some BGP packets going across, but it should be very, very few packets going across. It's hard to see, the number is too big, but trust me that the number is
Oh,
much
we
smaller.
absolutely trust you.
How about this? We'll do it on the actual access interface, so then there's no BGP packets. We'll make it a little cleaner. So this is my port 1, which is my actual server facing interface. Oh. I mean, it's hard to see the value. I must admit the size of it is not working. Okay. Anyway, ignore that piece. Trust me that the packets are going across. Trust me, the packets are going across the digital sandbox, right? So what I'm going to do now, actually, as the last part of the demo, is I'm actually going to, remember I said earlier that we synchronize state between the real network and the digital sandbox, so that's an option. I've actually enabled this in my environment. So I'm actually going to set my real network to be in a down state on the interface, my ISL, my uplinks, that port 31 we looked at earlier. And what I'm expecting is that my digital sandbox has that operational state set, right? So I'm going to admin down the port in the real network, which is going to trigger its operational state to go down, obviously. And I'm expecting the digital twin's operational state to go down as a reflection of what's happening in the real network. And I'm expecting that ping to stop. So let's start the ping that we know works so well. And we are going to now, I'm going to monitor the operational state of the interface on my digital twin. So you can see it switch from up to down when I actually do this in the real network, right? So firstly, I'm going to use port 31. So if I do an interface Ethernet port 31 brief. So on both sides, show interface Ethernet. Come on, there we go. 31 brief. So this is the equivalent port in both, right? This is my inter-switch link between my top of rack and my spine. They're both admin enabled, and they're both operationally up. And what I'm going to do now is I'm going to monitor on the DS side, so on the digital sandbox side, on change interface Ethernet 31 oper state. All right, so I'm gonna ask the system to tell me as soon as there's a change to the operational state of that port. And on the real network now, I'm going to jump down and I'm actually going to set the port to down. Right, admin state disable. So I'm disabling the port in the real network. So the oper state should go down, and I'm expecting you to see at the top that the interface actually also goes down. And it happened, right? So you can see here the oper state went down. And if I look at the interface, you can see now that the interface in my digital twin, its oper state is set to down based on the fact that the oper state in the real network actually went down. Now we know that's because I triggered an admin state, but of course the operational state could go down in a real network because of transceiver issues or fiber issues or whatever reason that might be. Yeah.
It says the admin state's enabled.
Yeah, because what I'm syncing is not the configuration at this stage. I'm configuring the state, which is actually, I can go back to the UI and you'll actually see that it'll ask me if I want to. It tells me there's a deviation on that fabric because someone went in, me, through CLI, and I changed something. So that's the point we talked about earlier. So I could actually rebase the config.
If you approve that change, it'll show up in the twin then, right?
I'd have to rebase the config. So I could, yes, I could do that. But I'd have to tell it, because remember when I went and I said duplicate, I said take it as it is.
Yeah.
All the inputs are the same. The input at the time was admin state enabled, right? So that's my baseline from a configuration standpoint. And what I'm doing now is I'm syncing the state. So for whatever reason, the state is operationally down. We know it's because I went and admin downed it. And I want the state to be reflected in my digital twin. And I could now say, if I wanted to, I could say I accept that change as an intent, and I could push that to my digital twin. So my digital twin could show admin disabled as well. But hopefully my ping stopped. It did. Success, right? So that was my ping in my digital twin. So the port is operationally down. and I set the ping stopped, right? Now, the last thing I want to show you very quickly is that this is all being shown in Fabric Services System as it would for the real network, right? So all the alarms, and this is optional, but all the alarms that a real network generates, the digital twin can also be generated in your Fabric Services System. And where this is important is for, again, upskilling your operations teams, your engineering teams, to understand the impacts of what happens in the network in certain scenarios and how to troubleshoot them and see them through the system they're going to use for the real network, right? So if I go back to my digital twin, my Fabric Services System UI, and I go to my alarm list, for instance, I expect to see a bunch of alarms that are related to BGP, to interfaces going down, BFD potentially. Okay, so you can see in my BGP adjacency down, I'm getting alarms for the real network, obviously, because I brought down the interface, but I'm also getting alarms for the digital twin. Right now, of course, you may not want that in your real, you may not want to actually see the alarms in your real production environment for a digital twin potentially, but potentially you do, right? And so what I'm seeing here is I've made an impact to the real network. My digital twin is reflecting that impact, and everything operationally is following suit, right? And the last piece of the demo is if I bring this back online, I expect the state to also follow suit. So I'm going to monitor the opera state is currently down. I'm going to bring the interface back up on my real network. And you can see the opera state change to up in my digital sandbox. Yeah, go ahead, sorry.
I was going to ask while you're bringing this up.
Yeah.
So I can imagine that having the digital twin like you're talking about is great if you're a team of like one.
Right.
But as soon as you start getting more than one person working on the digital twin, then you start running into all sorts of problems that ends up, you know, the reason why people come up with some sort of source of truth.
Yeah, absolutely.
You talk to us about how you solve that problem.
Absolutely. So we actually can instantiate any number of instances in digital twin. So every single person can have their own digital twin if they want to. The single source of truth is always the Fabric Services System, right? So as is with any kind of intent-based fabric management system, the implication is that the source of truth will be all the inputs that you put into the Fabric Services System. I can go back, I can do it again. So I have my real network and I could duplicate this another time, right? So as another user, you know, I'm a secondary user, I can build my own digital twin of the exact same production network, right? And I would expect that my state also be reflected of the real network as well, right? So I can, and this is one of the key parts of being built on Kubernetes is the scale aspect. Because then you will say, well, yeah, but this isn't scalable. I mean, how are you going to build so many copies of the same thing, right? So the only thing to do that is to have an infrastructure to support it.
Okay. I actually was kind of off on a different tangent than what you were thinking about.
Okay,
so I
sure.
was thinking in terms of, you know, I've got, so everybody here has got a digital twin.
Yeah.
You know, only Aaron's got the authority to actually push changes. The rest of us are just, you know, fooling around.
Sure.
You know, is there a mechanism to say that, you know, only Aaron's changes can get pushed, or, you know, only Aaron can affect the source of truth?
Yeah, absolutely. So there's an RBAC system. Yeah, we have an RBAC system in place. Of course, having the digital twin and making the changes in the digital twin is only allows you to test the results of the change you want to make. If you're happy with the changes you're making, the next step obviously would be to push that into the production, right? And at every step of the way, you have an RBAC system in place to control who has rights to A, instantiate digital twins. Once they're happy with the test, B, make changes to the real network based on the inputs that were generated for the digital twin and tested in the digital twin first. And I'm going to wrap up my demo there. Just I have Philippe to do another great demo after me. I just want to point out my ping is working again. And I definitely won't point my finger to Bruce at all about his ping, but my ping is definitely working. And it's pinging between my containers inside my Kubernetes cluster on my digital twin environment after bringing the port online in my real network, right? And that's the key aspect of this.